if you guys are interested, we got a lot of stuff going on in this booth, a lot of different Alexa game opportunities. We have AWS, GameSpark, Twitch, Game On, Lumberline, and my favorite, Alexa. So with all of that in mind, if that interests you guys, I encourage you to check out the booth. But today, I'm here to talk to you about, we also have some cool things that you can find out more inside our booth. But today, I want to talk to you guys about Alexa, and specifically Alexa for games. How to bring a player's voice into a game. My name is Cami Williams. I am a senior Alexa evangelist. You might be wondering what an evangelist is. Essentially, I'm a software engineer, but it is my job to teach and inspire people how to use Alexa, specifically how to use Alexa within games. So just some side notes. I really, really like Java. That's my favorite programming language, and my favorite game is Minecraft. So let's talk about voice. Voice in the game for a second. You might have obviously seen, especially over here in the Fortnite area, there's a lot of people screaming and yelling at their screens. There's also a lot of different features in games where you can talk to people in the gaming community, talk to people playing with you. Voice has always been in a game, whether we like it or not. Now, wouldn't it be great if for you as a developer, you could utilize that in some way? Take pieces of what your gamers and users are saying and incorporate that physically into your game somehow. Well, you can do that with Alexa. So we have an Alexa skills kit. Essentially, it's making apps or skills, as we call them, for Alexa. The skills kit gives you access to every Echo or Alexa-enabled device out there, specifically sold by Amazon. So just a quick overview, what that looks like. A user will say something, and that is taken in as audio to your Alexa-enabled device. That is then taken up to the cloud, and that is where the Alexa Skills Kit does speech recognition, machine learning, NLU, ASR, all of those keywords that are really impressive, and formulates a JSON request. That JSON request is then sent to your service. That can be hosted behind an HTTP endpoint or in AWS Lambda. And you then write Alexa's response, what she will say back to the user, how she will interact with your gamer. That's gone back up to the cloud. We do text-to-speech through SSML, all that good stuff. There can also be a visual component added to that if you have multimodal devices or if you want to send things to your user's phone. And then that's served up to the user. And that's essentially it. That's the Alexa Skills Kit in a diagram. Now, everything that you see in this cloud, the Skills Kit does for you. So all of the deep technical machine learning and AI understanding, we handle that for you. For you guys as the developers, all you have to do is say what the user could potentially say, and then write how Alexa would respond. And that's it. It's pretty simple. So let's talk about that in a gaming perspective. Now, before I got involved with Alexa and voice, I was a web developer, so I made a couple of web games, and I always wanted to incorporate somehow voice, being able to talk to a screen, whether it was for accessibility readings or just reasons or just adding voice into the game. So for a quick demo, I don't know if any of you played Tamagotchi before. It was like a little device that you could play in like the late 90s, early 2000s. Neopets is also pretty similar. Essentially, it's taking care of a pet. So I created that, and I have a quick video to show you, but essentially it's a blob, and it has different levels. It's pretty self-explanatory: hunger, energy, happiness, and you can take actions by pushing a button, but wouldn't it be cool if those actions could also be read by voice? And again, this could be an accessibility component, or if I'm away from my actual web application, it would be great to make sure that my blob was okay and that he was getting fed properly and tired or sleeping and whatnot. So you can't super hear, probably because I'm talking, but essentially I just said, Alexa, tell my blob to go to sleep. And that energy level increased. And it's working because you can see her little lights are understanding. So I very simply was able to incorporate voice into my game. Now, how did that work? Well, as with any web application, I had some sort of GUI component that I wrote. I hosted it on S3, which is an AWS service where you can just host images, videos. I hosted my website. And that is read into a service that touches DynamoDB. Now, DynamoDB, for those of you who aren't familiar, it's essentially database. It's a NoSQL scalable database that AWS provides. So within that database, I have my primary key as a user ID, and then I have levels. So I have a hunger level, happiness level, and energy level. So essentially all those stat bars. And it's just a read-write to that database, and the GUI component is affected as such. Then in my voice service, I have my dialogue model, which is essentially my skill, what the user says, how Alexa responds. That reads to Lambda. Again, it can also read to an HTTP endpoint. Lambda is basically a service that AWS provides that hosts your code for you. And then that reads to the same DynamoDB table. So in my skill and my web application reading to the same DynamoDB table, essentially they're able to interact with each other. Now, obviously, as game developers, a lot of our games aren't this simple. Alexa can also read to different game engines, and we'll talk about that a little bit later with Echo buttons. But I want to show you a little bit how easy it is to incorporate Ask into your game. And Ask is the Alexa Skills Kit. So a couple quick things before we dive in. Just want to break down what a user could potentially say. So Alexa, tell my blob to eat its dinner is something that I could potentially say. Alexa is obviously our wake word. Then we have a launch phrase. This could be tell, open, play, whatever you have. This part of the phrase actually isn't pertinent to what you need. It's just there so that way it sounds more natural. Then we have the invocation name. This is your skill name or your game name, your app name. So essentially what you need to tell Alexa to open, and the utterance is the action. This is what I want you to do. So this utterance points to a function in my service. An intent is a function. So I have a feed blob intent in my service, and this utterance is training data that points to the intent. Now, at this point, you might be thinking, okay, it's training data, so obviously, as with any AI, the more training data I have, the more accurate it will be, so the easier it is to point to this intent. So how do I think of everything a user could potentially say? That's impossible. You can't do that. So I typically suggest 10 to 20 utterances per function. So I could say to eat its dinner, it's time to eat, go out to eat, breakfast time, dinner time, snack time, that sort of thing. Just different phrases that Alexa can recognize to point to this function. So this is the Alexa Developer Console. And essentially, this is exactly how you build it out. So I specified my feed blob intent up there. And then I have all of these utterances pointing to that intent. So if a user says this, or anything similar to it, or anything that Alexa could potentially interpret to one of these phrases, that'll be pointing to the intent. And that intent, again, is hosted in my service. So right now, we're building out this interaction model. You might also be able to see all of my intents are listed on the side. So I have a name blob intent. I could say, name my blob Matt, or name my blob Thomas. I also have new blob, essentially starting over. And then I have these built-in intents. So Amazon has some keywords that you can't use in your utterances just because they are trigger words that can have her do other things. So in my case, I just account for cancel, help, and stop. And that's just typical for any game. Programmatically, this is what it looks like. It's just a JSON file. I have my interaction model, my invocation name or my skill name, my game name, and then I specify the intent and the sample utterances for that. Again, very simple programmatically speaking. So now I mentioned the name intent before. As with any function, you can have a variable to that function. So the variable would be the name. I called my blob Matt. So that name would be passed as a variable into my service, and I would get that from the user. That variable we call a slot. Now there are built-in slots, but there are also custom slots for Alexa. So US first name is a built-in slot. That's something that I used. If I have have an obscure name, I can also add on to this slot different names that I want to account for, but there's a lot of names in there, so I wouldn't worry about that. Other built-in slots include food, states, artists, music genres, a whole bunch of stuff. So we have a lot available to you. But like I said, again, you can also build your own custom slots. So I made an unofficial Pokemon skill. So I trained Pokemon names, and that was a slot that I made. And again, in order to add that to an utterance, you just include that as a variable. Pretty simple. The JSON for that is also just as simple as it sounds. You just specify the slot or variable name and the type. So the type would be US first name. And again, totally customizable. So now let's talk about persistence. How do we maintain context within the session and across sessions? So when you're using Alexa, you want to make sure that there's enough variance within your skill. If we were to talk about games and we had the same conversation every time, that would not be a good experience. It's very different from typical GUI experiences because if suddenly a button moves from up here to down here, users will get really, really mad. With voice, it's a little bit different. You want some variance. So in order to achieve that, we also can connect DynamoDB. So that is what I use to maintain my users' stats. I can also use it to hang on to a user's favorite color or their name, the last time they opened my session, things like that. All of that is provisioned by an Alexa user ID. And in order to integrate this into your Alexa skill code, all you have to do is specify your AWS region and then the DynamoDB table name. And that's essentially it. Now I'm connected to my DynamoDB table. And if I want to edit the attributes of that table, I just say this.attributes name, hunger, happiness, energy, anything associated to that user ID. It's the same process for reading, writing, creating new tables, creating new items in that table. It's very, very simple. So within this, you can see I have my launch request. This is what is called as soon as a user invokes my skill. This is the sleep intent, so essentially the training data I have pointing to that sleep intent. All of this is hosted in my AWS service. So if you remember that cloud diagram, it was the area on the left. That's where we're at right now. Okay, so now variety. You may have noticed walking around the booth, Alexa is able to say things beyond just in her normal voice. We have SSML integrated into Alexa's response, so you can incorporate audio or speech cons, things of the like. And so I do that within my code. So in order to access that variable, you just jump into the event request, into the intent you're in, and then access the slot. And you can incorporate that into how Alexa responds. You can also include interjections. So if instead of Alexa saying, wow, she would say, wow, there would be some emphasis, and that's interpreted as an interjection. And we have a list of those. And again, it's SSML, so it's very easy to incorporate. It's just surrounded by tags. And that's essentially a wrap-up of the Alexa Skills Kit. But now I want to dive into Echo buttons, because I'll get to your questions in 1 second. That's kind of the meat of what I want to do. So Echo buttons is something new to Alexa and to Echo devices. Essentially, they're a button that connects to a game engine that can incorporate different actions for Alexa. So in my game, I'm going to fast forward this a little bit. I push the buttons, and those buttons are associated to the different buttons on my screen. So you can see the purple is feed, green is nap, the orange will be play. And I'm speaking to Alexa right now, and she's telling me to hit the buttons. And so when I hit the purple button, which is feed, takes a second, and the hunger level goes up. So essentially, it's using Alexa beyond her voice, but also incorporating a physical attribute. So the first part of incorporating buttons is roll call. You need to specify what buttons are going to be used and how many are going to be used. So that was just me in the beginning tapping the buttons. In order to do this, first we need a recognizer. I want to recognize that I'm looking for a button down action. This is again in my service code, so I just specify button down. Then I start the game engine. So this game engine is pretty typical to any of our standard game engines. We're looking for recognizers, and we have events that are coming in. I start that handler, and so I'm looking for these game events, and then I'm iterating over them. If I see a button down, then I register that button, if it's a new button. And then I can specify animations and light events and things of the like. So something specified this way, you just name it as a shedding light event on a button down. And then I can say I want it to apply to this ID of the button, and I want it to be purple or green or a hex color for a button and have an animation length. How long do I want it to be that color? Now, if you add a new directive, that'll override the one that you currently have, or you can queue them up. And then finally, assigning functionality to them is just associated to the ID. So if I have a new button and it's the first button I pressed, then I know that I want to point it to the feed intent. This one would be the sleep intent, and then this one would be the happiness intent. And there are different colors associated to each, and I'm pointing to its button ID. And then beyond that, I can see if I have accounted for all the buttons. That means roll call is done. So I set roll call to true. And then I specify that it's time to look for the behavior. So if I see the button ID and it's indexed as the first button they pressed, I just step into those intents. And assigning functionality to buttons is as simple as that. So with all of this in mind, you get a seamless process between a user speaking to your Alexa skill and essentially is speaking to your GUI component. Again, this is great for things beyond GUI-related applications because you can check in on your game while you're not in front of a screen. But you can also create games beyond that. And there are a lot of different resources that we have that you can look to after this session or after GDC. We have a design guide to help you design for voice. We have some standout skill tips. Each week we host office hours on Alexa. That's 1 hour a week where you can talk to evangelists like myself and get one-on-one help. And then finally, you can get paid if you make an Alexa skill. We have monetization that's coming to Alexa, but beyond that, Amazon will reward you if you create and publish a skill. So that's at Dev Rewards. So if you want to learn more, I definitely recommend checking out the rest of this booth. We have 2 Alexa booths going on. The one on this side is about Echo Buttons. The one over there is on Destiny 2. We have classroom sessions coming up. You can see a list of them there. And then finally, we have all these great Amazon services for games. And that's more animations. And I want to thank you all for coming.